Hey guys, just wanted to explain a service called DHCP. In case some of you guys are struggling with this or you're just getting into networking, I figured I'd try to help you out a little bit on understanding this concept. I know I kind of struggled with this and network address translation and kind of the differences. We aren't going to go into that too much. We're just going to go over DHCP today. And so DHCP stands for Dynamic Host Configuration Protocol. And I figured I'd just give you kind of a little picture here, kind of representing DHCP. However, this is a representation of DHCP relay. It is using a router to connect the DHCP client to the DHCP server. We'll talk a little bit more about that later, but right now let's just kind of get into DHCP a little bit more in detail and why we even need it. Well, DHCP gives out IP addresses and subnet masks to hosts on the network automatically. So we as individuals don't need to go in and statically configure our own IP addresses on each of our devices, which, trust me, would be an absolute nightmare. And we can talk a little bit about that more, kind of like the human errors and everything that goes on in that a little bit. However, in the world of TCP IP, the word host or client refers to any device with an IP address, your phone, your tablet, a PC, a server, a router, a switch, your wireless house temperature setting in your home, any device that uses IP addressing to provide a service or just needs to be managed by an IP address, or not by an IP address, but just needs to be managed, and so the device, in order to be managed, has to have an IP address. This is where DHCP comes in. DHCP automatically hands out IP addresses to hosts, allowing your smartphone, your computer, your TV, or any other device on your network to provide you with services from the internet, or just to connect you to another network. DHCP can be statically configured to hand out permanent addresses, but in most cases, it just hands out leased addresses to hosts, which in layman's terms is just a temporary IP address. Usually they're configured to be handed out for 3 days is the typical time frame for a DHCP lease, which means your client or your host will hang on to the IP address from the DHCP server for 3 days before it ends up either renewing or getting off the network or changing IP addresses. One of the benefits to this protocol is this protocol offers fewer human errors, like we were talking about before. Because it automatically gives out an IP address, rather than having to manually go in and assign IP addresses to every computer and promote human error on your network, individuals could end up setting the wrong IP address or subnet mask, or assigning overlapping IP addresses, or even assigning an IP address that doesn't even belong to your network, which wouldn't allow it to connect with your other devices or the internet. So this is why we want to use DHCP. It cuts down on the human error and also just automatically provides these IP addresses free from human error and hassle-free. We don't really have to touch anything. We just have to set up our client to handle DHCP, and then it automatically goes through that process and requests an IP address from the DHCP server, along with some DHCP options, which we'll go over here in a little bit. But yeah, I just want to bring that to you. But how does DHCP actually work? Well, information between electronic devices everywhere around the world transfer data between each other via two main processes, two main transfer methods, one of which is TCP and the other is UDP. For all intents and purposes, we aren't going to cover these two ways of transferring information between devices in detail. We will leave that for another day. Just know DHCP uses UDP. This is important because this means that the DHCP packet that is sent across the network is sent with a UDP IP header. Think of this header as a mailing address sticker on the outside of a package. This mailing address sticker that is on the outside of every package is basically telling every delivery person where to send the package. Think of you're ordering packages off of Amazon and then they just magically show up at your door. How does that happen? You know, the delivery driver is looking at the address on that sticker, the outside of that package, on where to ship that package, on where to send it. Just like this mailing address sticker, the UDP header is telling each device where to send it on the network. This header is important because it tells you the source and destination IP addresses and the MAC addresses of each computer, as well as the port numbers. Now, every computer has a built-in unique MAC address hard-coded on it. But not every computer automatically has an IP address. The important the port numbers, which are important as well, are sent with the IP addresses, so devices know what and who the packet is for. For instance, DHCP ports are 68 and 67. 68 refers to the client, and 67 refers to the server. Now, how does this play in the UDP header? Well, I have a picture for you to kind of show you exactly what's going on. Now, I clicked on the packet on the router, okay? And so the packet went from the client, okay, it's a discovery message. It's going all the way over to the router. Excuse my horrible drawing here. I'm doing that with a mouse right now, but bear with me. So layer 4 is the transport layer, okay? This is using UDP instead of TCP. And then on top of that, it's using a source port of 68 and a destination port of 67. So what's that really telling us? So what it's telling us in this UDP header is basically it's saying, hey, for layer 4, the transport layer, we're going to be using UDP as the header. And then on top of that, we're using DHCP ports because it's using 68 and 67. Well, if you recall, 68 is the clients and 67 is a server. So this is saying, hey, this packet is coming from source port. It's coming from 68, which is basically saying it's coming from a client DHCP device and going to a DHCP server 67. So it's saying, hey, transport layer, using UDP, it's coming from a client device going to the server, which can only mean it's probably requesting an IP address. And some DHCP options. And then on layer 3, we're talking about the IP address, and layer 2, we're talking about the MAC address. Let me talk a little bit about that right now. The IP header is telling us the source and destination IP addresses. The source IP address for this is 0.0.0.0. Well, what's that mean? Okay, source meaning it's the current device's IP address that this is coming from. And so since it's coming from the client that we can see up here using the port numbers, it's coming from a client, and the client's basically saying, hey, I have no IP address. That's what this 0.0.0.0 means, is I don't have an IP address. I need one. And then the destination IP address, 255.255.255.255, is basically just a general broadcast. And so this message is going out to any and everyone on the network. And the reasoning for that is because this device, it must have been just introduced into the network or just turned on the network. It doesn't have an IP address from the DHCP server on the specific network. And on top of that, it doesn't even know where the DHCP server is on the network. So it's going to send a broadcast out to everyone on the network. In this example, all we have is a client, a switch, and a router acting as a DHCP server. So even though it's sending a broadcast, it's really only going to one device. If we had more devices plugged into the switch, it'd be going out to those devices as well. But I just wanted to lay down a simple illustration to help us understand this first. And so it's basically saying, hey, I don't have an IP address, 0.0.0.0, destination 255.255.255.255. It's yelling out to every other device, hey, I've got a message for you. You go down to layer 2, okay? You have your own burned in MAC address. That's no problem. every device has a burned-in MAC address and it's unique. But again, it doesn't know the server. So it has all Fs there, trying to find out who the server is or what their binary burned-in address is. So I think it's important to talk about, if your computer doesn't have an IP address, how does it end up getting an IP address? How does the DHCP server even know where to send the IP address in the first place? Well, the host gets an IP address through a process, a DHCP process, called DORA. Again, if you follow DORA, DHCP D for discover, DHCP O for offer, see DORA, discover, offer, request, acknowledgement. This stands for DORA for short. It's a kind of an easy acronym to kind of help you remember the process. Now, it is important to know that each of these messages in the process of DORA, that is discover, offer, request, acknowledgement messages, all take place within seconds. This process is incredibly quick and almost seamless. So what happens when your device is introduced into a new network? It will automatically send out, if it is configured for DHCP that is, a discover message or packet, if you will, to the DHCP server. This DHCP message is a broadcast message. Broadcast message meaning it just sends the packet to all the devices on the subnet. However, every device seeing the packet and then figuring out that it is not for them because they are not DHCP servers, just looking at the port numbers, like we talked about earlier, will reject the packet. Only the DHCP server who sees the port numbers and the discover message will accept the packet. And when the DHCP server gets this message, it will see the packet header. The packet header is important because, if you recall, it is like the house address sticker that we talked about earlier. But the only problem is that this IP header doesn't have an IP address associated with it. So how does the DHCP server know where to send the IP address that is supposed to be assigned to this specific device? That's a great question. Let me explain the packet header first. So since this host does not have an IP address associated with it, it will send out a source IP address. Source IP address is just another way of saying this device's IP address as 0.0.0.0 right here. So the source port IP address, or I'm sorry, not the source port, the source IP address is 0.0.0.0. It just means it doesn't currently have an IP address and it needs one. Since it does not know the IP address of the server, hence why it sends the broadcast message, the destination IP address, which is the IP address of where this packet will end up, but your device doesn't automatically know where the server is, which means it doesn't know the IP address of the DHCP server. So it sends a broadcast packet out, which means the destination IP address is going to be 255.255.255.255, which is just a broadcast out to every single device on the network. But the router is the only device that rejects broadcast. Think of broadcast like yelling out to a room. You're going to end up messaging everybody in the room when you yell out because everyone's going to hear you. Just remember, routers hate being yelled at. So any broadcast that goes out to a network, a router is automatically going to slap down and disregard. It isn't going to take broadcast unless configured to do so. Now, whenever a packet goes out, just like how it has source and destination IP addresses, it also has source and destination MAC addresses. Now, for the source address, like I stated earlier, every device has a unique MAC address, which is also its source address. So the packet goes out with its source address of the device, no problem. However, the destination MAC address is a problem. Because not only does the device not know where the DHCP server is, but it also doesn't know its MAC address either. So it doesn't even know what a device it is. So for the destination MAC address of the discover packet, puts ff.ff.ff.ff.ff.ff. That's a lot of .ffs. Or it can present the MAC address within 2 just dots. So it'll have 4 Fs, a dot, 4 Fs, and a dot. It just depends how it's presented. You can present it and be like, I think it's presented in 3 different ways. I forget the third way MAC address can be presented. But just keep in mind, when you see all Fs in the MAC address layer, which is the physical layer, or not the physical layer, the data link layer, I'm sorry. Layer 2 is the data link layer. And when you see a MAC address in the data link layer or the layer 2 address as all Fs, basically, it just means it doesn't know the MAC address of the device it's sending to. That's all it basically means. So to summarize this, the packet header is basically saying, I don't know who the DHCP server is or where it is. Hence, I don't know its MAC address or IP address. So I'm going to broadcast this message out to everyone. And I don't have an IP address, so I need one. Hence the 0.0.0.0 in the source IP address. But it does know the port numbers. So everyone should read this as a DHCP message just based off the port numbers. Once this goes out and hits the DHCP server, the server will look at the packet reading the discover message being the first message coming from the client to the server, like we talked about, from the client, which is port 68, to the server, which is port 67 for the DHCP ports. Seeing the port numbers, realizing, hey, this packet is for me, and this is a discover message. It will then send out an offer packet, or message if you will, back throughout the local subnet. So this client can receive the packet, but the host does not have an IP address yet. So how does the server know how to find it? Well, the server, in short, doesn't know how to find it, just like the client doesn't know how to find the server. So it yells back to everyone else on the subnet, hey, I've got an IP address for you and some DHCP options. So basically the server sends out another broadcast message, hitting everyone on the subnet. Now all other clients reject this packet because the packet has a DHCP client ID. Just remember the DHCP offer message or packet has the client ID within it. Okay, that's how the client knows, hey, this IP address and DHCP options are for me and not for anyone else. And that's how the other devices know, hey, this IP address and these DHCP options aren't for me. So I'm going to go ahead and disregard this and keep the IP address that I have. Otherwise, everyone else would end up with the same IP address. This client ID is basically the source MAC address of the recent DHCP discover packet. So the client sent the discover packet out to the server. The server saw that and it saw its MAC address wrapped up in the client UDP header. So it's going to use that MAC address as the client ID, put that into the DHCP offering so the right client gets the IP address and the DHCP options. But when it is a right match for the host MAC address, the device accepts the packet, opens up the offer, and sees the IP address and the DHCP options and is like, hey, sweet, I want this IP address and these DHCP options. I want to lease them from you. So the host, after receiving the offer packet, offering the DHCP information, will send out a request to keep these DHCP information and options, IP address basically, and use it for a while. It wants to lease these out, so it's going to request this. Hence, why these messages are called the way they are. DHCP discover. It's trying to discover a DHCP server on the local network. And if it can't, like we talked about a little bit earlier, which we'll get into more later, it's just going to send it to a router which would be configured to be a relay agent. Let me see if I can't. No, I already got rid of that. But yeah, it's basically the same thing. It's going to offer up a discover message, and then that message is going to be seen by the server, hopefully. And then the server is going to offer DHCP options and an IP address, and then that client's going to request those options that were in the offer. Okay. And that's basically how those three steps kind of work, and how they are kind of working as labels in and of themselves. So it helps you kind of remember DORA, the process, discover, offer, request, and eventually acknowledgement. We're going to get to that here in a second. So the host sends out the request packet back to the server the same way it sent out the last packet, to tell the server that it wants a DHCP option, or it wants the DHCP options that it was offered, and the IP address. And the server sends the final packet back out to the host after receiving the request packet, known as the acknowledgement packet. This is the final packet sent in the process of receiving and giving out an IP address. And when this packet is handed out, the server marks off the IP address that it handed out and assigns it to the specific MAC address. So now it knows that that IP address has already been handed out, and it knows which device has it because of the MAC address that it's assigned to. Remember, each device has a unique MAC address. And so when this IP address is assigned to it, you know exactly which device on your network has that specific IP address. So now it knows who the IP address is, or who has the IP address, and who it currently is leased out to. So it doesn't assign that IP address to another client, which is really important because you don't want overlapping IP addresses. Then you'll have all kinds of problems. Now, how do we know that after this whole DORA process, DHCP actually worked? Well, if you open up your IP settings on your computer, you're going to see an IP address, subnet mask, default gateway, DNS server address, and other processes that work. If it doesn't work, you're going to see in the IP address range 169.254.x.x as your IP address, and the other fields will be empty. That's how you know it won't work, or it didn't work. So let me get on here and give you kind of a visual representation. Just go to your network. Go to, I believe it's right here. Yes. Change adapter settings. Right click. Properties. Yes. Or, oh, I'm sorry. Give me 1 second here. It's been a while since I did this. Properties. All right, there we are. So as you can see, my obtain address automatically, which is code for DHCP, is already set up. I have, however, changed this because I found my network works faster with these specific DNS servers as opposed to just obtaining one automatically from my ISP provider, or my internet service provider, sorry. So that's one way you'll see that it worked. Right now, obviously it's working right now because I'm connected to the internet and I can search up things. But you're going to see if it doesn't work, it's going to have that, what did I say? 169.254 dot, whatever. It's not actually going to be X's. It could be 0 to 255, 0 to 255, anywhere within that range for these last 2 octets. Just know for the first 2 octets that it's going to be 169.254 dot something. And the rest of these aren't going to show, just like they are right now, I guess. But this part, the IP address, it'll show the 169.254 that it's not working. So speaking of the DHCP options that we just kind of talked about, here's a better representation of them. So it shows the IP address. You know that it obviously worked because it has the IP address assigned of the specific network that I have. It also has a subnet mask, which is an option, and then a default gateway, which is another option, and a DNS server, which is another option. And so basically when I was saying that the DHCP server is sending the IP address right here, and then options basically include all three of these. And options can include a little bit more as well, like a domain name and other stuff. But that's a little bit beyond the scope of what we need to know for DHCP. Just know that whenever options are mentioned, they're usually talking about a subnet mask, a default gateway, and a DNS server. Because you need those three things to be able to connect with the other devices on the network and to be able to connect out to the rest of the world. Okay, you need an IP address as well as the DNS options that it hands out. Unless you're going to manually configure all this, but like I said, it's so much better just to have a DNS server. So the DNS IP address is basically used to find a server which will change the types names that you type in online, like youtube.com or amazon.com or whatever sites you use, into IP addresses, because every website has an IP address. Okay, and in order to get there, you need to know the IP address or the name associated with it. And since it's a whole lot easier for us to remember names as opposed to just 32-bit IP addresses, like who's going to remember, 192.168.0.4 is my device. And so every time I want to go in and manage it, I'm just going to go ahead and type that in. Like, no one's going to remember that. You know what I'm saying? Like, but they will remember youtube.com or amazon.com, which each of those names have IP addresses associated with them. And that's what your DNS server does. It changes those names into the IP address so it populates that server or it populates that website that you want to go to. So DNS server is a very important DHCP option that you need to have on your devices, unless you just memorize every IP address out there. And your default gateway is basically the router to your local subnet. And by local subnet, I mean, like, if you're at home right now, in order to get out to the rest of the world, you're gonna need your router's address that's connected to your network. And that's what the default gateway is. And so the default gateway is basically the gigabit 0.0 port right here. That's what this computer is connected to on this router, which will then take the information that's going to it and send it out to another network if need be, if it's configured right. And so you're definitely going to want that default gateway because that allows you access out to the rest of the world. Your subnet mask is very important because your subnet mask helps define the network that you're on based off of the IP address that you have over here. So I have 192.168.0.4. That means I'm a part of the .0 network because it has 255.255.255.0. It's a basic class C subnet, and it basically just says, look, any of the matching up decimal points or decimal sections that have 255 aren't going to change. So the 192 is right above the 255, the 168 is right above the 255, and the 0 is right above the 255. So that part of this network IP address isn't going to change. The only part that's going to change is this host portion, which is 0. And so since it's labeled 0, that means it can go from 0 to 255. But the only usable addresses are going to be 1 to 254 because 255 is a broadcast. Remember, that's always saved for broadcasts. And so this basically says, hey, I'm 192.168.0.4, which means I belong in this local subnet right here, this broadcast domain. And so this 192.168.0.1 also belongs into it, but that's the router's IP address. So not only does it know its own IP address, but it knows the default gateway address, the router address, to be able to reach the rest of the network. And so these options are very important, and this IP address is very important. And that's why when the DNS server sends an IP address, it doesn't just send an IP address, it sends the DHCP options as well. So I just wanted to take some time to kind of talk about those and why it sends those and why those are important and how those play into your network. So DHCP takes care of all these options which allow you to have access and connect to the rest of the world, like I said before. Better yet, it does it automatically so that you don't have to have a configured settings on your own. You won't go in there to each and every single device in your home or in your business and go ahead and individually sit there and configure IP address settings and or DHCP option settings for every single device. Imagine if you had to do that for like 300 devices. You're definitely going to have some human error in there because there are going to be times where you're just not thinking and you're inputting certain numbers, or you kind of, how I call it, fat finger a couple extra numbers in there, or you miss a number because you don't accidentally type it. Just all kinds of human error can occur. But DHCP automatically sends it out for us, which is so nice. So this basically, you could go into every computer on your network and configure all these settings, but why? It basically is what I just said. When you can configure everything using DHCP and have it auto-populate everything you need for your devices, that sets it right up. Your auto configuration of DHCP creates mobility with computers. So if you have a laptop and you leave your office or you leave your home network and you go to a coffee shop and you want to be a part of that network, using the free Wi-Fi, having a device configured using DHCP, you'll be able to get on the DHCP options and the IP address from that gained access online using the free Wi-Fi from that coffee shop's DHCP setting, because it'll automatically be set up as well if it has free Wi-Fi, and you'll get all your IP address settings from that network. And then the next time you want to end up coming home and you want to leave that place and you want to get back onto your home network, DHCP takes care of that as well, since it's already configured. So that way when it boots up, it'll know, hey, this IP address doesn't work. I'm going to go ahead and send a discover message out, and then the whole process of DORA starts. Now that we have talked about DHCP, how it works, why we would want it, and the benefits to it, let's talk about DHCP device itself, the server. Usually it is a server or a router. A router could even be configured as a DHCP server. And sometimes it is a server that is not on your local area network. But when we talked about this process, it needs to be on the network, right? Well, that's where DHCP relay comes in. Yeah, this picture that over here that I talked about at the very beginning of the video. You see, the broadcast can be sent to the router, which the router then sees, and instead of rejecting the broadcast, the router sees it, is configured to accept it, okay? And then repackage it and send it as a unicast to the DHCP server, which the server sees, sends back to the router, which it accepts it, and then sends it back out as a broadcast to this DHCP client on this network. Now, when the router is configured with the DHCP relay, it will look at the packets with the port 67 and 68, and it will see that it is a DHCP packet. So it'll take the packet and act as a middleman of sorts. It relays the information to one device outside the network or broadcast domain to another. Now, when the server gets this message, it responds like we talked about earlier, and the relay router or device, it's usually a router, will see that it is a DHCP packet and will relay the information again, but this time to the appropriate broadcast domain where it can then be broadcasted out. So, to kind of sum that up, like I was saying earlier, this client broadcasts the message out, the router sees the port numbers, the source port being 68 from the client, sees that, repackages that to a unicast message if need be, send it out to the server The server sees it, sends it back to the router. The router sees the port number from the server being 67, realizes that it's coming from the server, sends it back out to the original DHCP subnet that the client was on. The client gets it, and that's how that basically works. The router is just acting like a relay man, a middleman of sorts. It just relays the messages. All 4 messages that we were talking about for the door process, it just relays those to a server. So you don't have to have a DHCP server actually on the same subnet as the client if you configure the router as a relay agent. Now, to finish all of this up, I thought I would talk about a DHCP server details a little bit more. When you are configuring a DHCP server, you need to have a subnet ID and a subnet mask configured for each subnet that the server will be handing out IP addresses for. The subnet ID is basically just the first IP address on the range of IP addresses that are going to be handed out. So for instance, if I had a standard IP address range of 255.255.255.0, which is basically a Class C subnet, it just means that the 0 has a range of 0 to 255 on the IP addresses that can be configured in that decimal value of the IP address, like we talked about earlier. So if an IP address was 192.168.0.1, if you line that up with the IP address right under the subnet mask, you're going to find that the first 3 decimal points have the value of 255. So the 192.168.0 are never going to change, which means the one with the 0 can change. And since it has a 0, it can hand out IP addresses ranging from 1 to 254, like we talked about, because 255 is a broadcast message and the 0 is the subnet ID because it's the first IP address. So 192.168.0.0 right here, 192.168.0.0 is going to be the subnet ID for this entire subnet right here. And then something like 192.168.0.1 could be the default gateway, which it is in this case. So when I say you need to reserve the subnet ID, I'm just saying you need to reserve the first IP address of the range of IP addresses that is defined by the subnet mask. Now, the options the DHCP server gives out also need to be configured. So the default gateway, the DNS server, and the subnet mask that will be handed out via the DHCP server also need to be configured for each subnet of an IP address the server is configured to manage. And when these options are sent out, they are technically leased out because they are sent out only for a duration, most likely. Now, you can send out permanent addresses for like infinite amount of time, but most likely it's sent out for 3 days, like I said before. Then the client can renew, or it can get another IP address with the same options. When a client or host does not renew the lease or the options, the IP address is put back into the pool of potential addresses to be handed out for another host on the network. So like I was talking about earlier with the coffee shop example, you grab your device, you take it off your network, and you put it in the network in the coffee shop, and it gets a DHCP address. It left the old DHCP or the old network that it was in. So after the 3 days expire, since your device is no longer on that network, let's say you took a vacation or something, you brought your laptop with you, and it's been past 3 days. So the duration has expired. That IP address, since it wasn't renewed or wasn't sent to your computer again, it's going to be sent back into the pool of IP addresses to be handed out to another device. And when you bring your device back, it's most likely just going to be handed out for your device. But that's just an example. Like, you're in a business area and you have a laptop. You take your laptop out after vacation. You're probably going to end up coming back and sending a new discover message with your DHCP server, getting a new IP address, if it isn't hard-coded. Now, the server also needs to exclude a number of addresses to be assigned statically to devices on the subnet that it is handing out of the IP addresses range. For instance, you don't want a server handing out an assigned address to a printer that you have on your devices, or any other statically or manually configured IP addresses on your network. So let's say I wanted to put a VLAN, or I wanted to configure one of the interfaces on this switch to statically have an IP address. So it's always going to be on there. It's not going to ask a DHCP server for an IP address. I'm just going to statically put one on there, and it's going to stay on there. Let's say it's 192.168.0.5 or .6, whatever. I statically put it on there. Well, over here, I'm going to want to make sure that doesn't get handed out. So just as I talked about earlier, you have your default gateway that you assign, you have your DNS server that you assign, you have your subnet mask that you assign, and then your ranges of IP addresses. So for instance, this says start of IP addresses, 192.168.0.4 is where I'm starting to hand out IP addresses. Now, what I could do is I could start that out at, let's say, 10. Because I'm using, let's say, 1 through 9 as static entries. I'm configuring a printer over here. I'm configuring a switch. I'm configuring a layer 3 multi-layer switch over here. I don't know. There could be tons of different things that I statically configure, and I could statically configure up to like 9 addresses. Okay, so I want it to start at 10. So 10 is going to be the starting range of which it's going to start handing out addresses. And so what I mean by that is when this guy sends out a request, a DHCP discover message, and it starts the whole DORA process, the IP address that he's going to end up getting is going to be 10 or above. 10 up to 254. Okay? Anywhere in that range. But it's not going to get 192.168.0.9 because I'm starting it off at 10. I'm excluding addresses 1 through 9. And I'm automatically going to configure that into my DHCP server, which in this case is just the router. When configuring DHCP server, you can allocate its options and IP address via 3 different ways. One way is dynamic allocation, which refers to the way that we've been talking about. Another way is automatic allocation. The only difference here is that the lease time is sent to infinite. You know how I said the IP address and DHCP options are leased out for 3 days? Well, on this, the IP address and DHCP options are, finger quotes, leased out, finger quotes, for an infinite amount of time because there technically isn't a lease. It is just handed out and that's that. I don't know why you would specifically go with automatic allocation, but hey, it's another option that you have. The third way is static allocation, which pre-configures the IP addresses based on incoming MAC addresses. So a client with a specific MAC address always gets the same IP address. You are literally linking each MAC address to the subnet to a specific IP address. So only the computer can receive that specific IP address. That takes a lot of work. And if you're doing that, you almost might as well just statically configure your IP addresses. I don't know why you would use this option, but hey, it's there for you. Most of the time, dynamic allocation, the process that we've been talking about, is the way that it's set up. However, these other 2 options of setting up a DHCP server and how it hands out the DHCP options and IP address are there for you if you want to do it that way. But that pretty much wraps up DHCP video for you guys. If you want me to talk about anything else or any other specific topics, please leave them in the comments. I'm just going to keep putting out these kinds of videos, and hopefully it helps you guys out. Thank you for listening.